Welcome, everyone. It's great to be here. I'm honored to have been asked by Diane to come present on how we do innovation at Red Hat. So, looking back over the years in terms of how we bring emergent technologies into really an enterprise-grade level, we look first, as we do is our ethos, into open source, where there's over 150 million different projects today to look at. So how do we do that intelligently, figure out which project has legs, is going to work, is interesting to our customers? Part of that is the co-collaboration that goes on. So we work hard to embed ourselves within these different projects and communities and to understand the challenges. We also talk to our customers. We talk about what are the sharp edges, what are the challenges, what is unique? And from that, we take the open source technologies from their infancy, create POCs, and eventually put those into product. So, as Diane mentioned, I'm in the office of the CTO, and we're structured into 4 different categories. We have emerging technologies, we have the open source program office, we have distinguished engineer vitality, and we have research. So you can see these 4 aspects really cover the gamut of innovation, community, and product. And so our ideas come from communities, customers, universities, even our partners at IBM. So the first thing that we do is we identify a project that we think is interesting or novel or fits a gap. From that, we then align with partners within the business to see if this is something that could potentially be productized. Then we go to develop a POC, and we don't just develop something over a day. We spend weeks. We make sure that this can actually be integrated into the product portfolio, and then what we do is a tech transfer. This way of working to evolve and innovate is fairly unique to Red Hat. It has actually been published recently in Pipelines magazine because of the success rate we have for most emerging technologies. About 90% of the different POCs that we develop actually land into product. But what I'm actually more proud of is the things we don't invest in, because many times we experiment and we fail. And so what's so important and unique is that within our culture at Red Hat and emerging technologies, we're given the psychological safety to fail, to say this isn't a good fit. We've invested the time, there's no sunk cost, we learned something and we move on. And this is a continuous evolution in terms of our innovation. Because we know today's experiment in open source is tomorrow's disruption in the enterprise. We take that very seriously. And living within that disruption, day in and day out, we understand the customer better, the community better, and the technology better. So, emerging technologies has 9 different focus areas. And if you looked at this slide 6 months ago, or you looked at this slide a year ago, it would have different teams, and it's very intentional. The idea is that we have small teams moving very quickly, and we create and reorganize as we need according to what the business needs. So today, the 9 different teams are really focused around security, computational infrastructure, edge computing, open services, data management, multi-cloud networking, sustainability, application platforms, and artificial intelligence. And that's a lot of different areas to keep track of. But today we're really going to focus on security, AI, ML, and how we manage those things within operations. I'm not going to go very deep today because I know, as Diane mentioned, we have a couple customers talking about their specific use cases, and so they will be touching on some of these technologies and how they're integrated into the portfolio. So what really has our interest today? Right now, it's development pipelines for AI applications, end-to-end security of those as we move things out to the far edge. When we're moving things out to the far edge, the compute there is changing. We're embracing ARM. We're going to be embracing RISC-V. How is that changing the way that we develop applications and workloads in a secure, consistent manner and at scale? And as we look to creating that data on the edge, what about data sovereignty? How are we managing and governing the data that we're putting at rest? And then lastly, how are we using these different computational infrastructure architectures to make more intelligent decisions towards a sustainable ecosystem? So these ideas come together in 3 different use cases that I'm going to go over quickly. And so we start, again, as I said, with cloud security, computational infrastructure, edge, artificial intelligence, and last, data management. So as a developer within the ecosystem, things change. Our developers have gone to just using Go to being data scientists within the ecosystem, contributing to the AI/ML models that allow corporations, communities, and projects to work more efficiently. But in doing that, we don't use the same tooling. And so that we as engineers need to make sure that the security underlining the way that we create these pipelines is secure from the time that they push the model out to be deployed. So once we do this and we embrace edge fully and create millions of devices out on the far edge, how do we actually operate and sustain being able to make sure that we can push the model, that the model is secure, and that we can take down devices that may have been compromised? That all goes into the challenges with operations. So how do we make it easier for data scientists to do their jobs? So first of all, they need to be able to create an AI/ML model very easily. They need to not rely on the traditional software engineering tools, but instead use the tools that are meaningful to them. Lower the bar for them to be successful. And part of this is maybe they want to work within a web browser using a Jupyter notebook to interact with it, change their model, understand, evolve. And so one of the technologies coming out of emerging technologies that is hosted by Project Meteor is called Bring Your Own Notebook. This is currently hosted on Open Data Hub. You can go out and try it yourself. What this allows is to be able to push your workload to the edge from that very easily. Build the model that you want, not worry about the rest of the engineer tooling, but be productive right out of the gate. So the end result of this integration really is more productive and happier data scientists. But once we do push that model out to the edge, since we are a data scientist, we're working within our browser, we have just opened up an opportunity to it not be secure. So as I mentioned before, it is our responsibility to make sure with the pipelines, once we push the model, that we're providing the security necessary to do that. So once the model is pushed using a webhook in GitHub, our Tekton pipeline is kicked off. That image within Tekton is then signed by cosign, which is part of the SigStore pipeline, and then pushed out to the device. So what happens when it's out to the device? The device might be a camera in a train station somewhere. We need to make sure that that device cannot be physically infiltrated and the container image changed. Therefore, we look at projects like Keylime, which provides attestation at the actual device to make sure that what I've signed and said is secure is actually running on the device. The cosign, SigStore, and Keylime all have been projects that have come out of emerging technologies, addressing the challenges unique to edge, to security, into cloud today. And so what does this happen? The data scientists can worry about what they want to do, but ensuring that we have the right build pipeline, we are creating more confidence in the end-to-end software supply chain. So how does this all come together? How do we manage this many devices when we start talking about edge? And so because we created a project that Frank will be talking about later called MicroShift, we're able to have the same ease of deployment as we would in OpenShift now out to the edge. So MicroShift is a project that was created to exactly address this. If I am used to the tooling, the pipelines, and the tools that I use in OpenShift, I want to have that same ease of use all the way out to the edge, but on a smaller footprint. I also need to make sure that I'm able to address the challenges unique to edge. Some do not have a great network. Some are very, very small footprints. So using MicroShift, our customers today will talk about how Red Hat Device Edge is able to take their OpenShift pipeline and expand it out to the scale that we need. So, successes. We all like to celebrate when things go right. And MicroShift recently in May actually went out into space. That's right, we took MicroShift into space as part of the Endeavour rocket. It was used to create a means of democratizing space by high school students can now publish their experiments up on the International Space Station and get data back using MicroShift. SigStore. SigStore that was created, which is conflated into many things, but includes things like cosign and recore, is now the standard in container signing within the industry. There was a recent article published that it will be the standard for things like Kubernetes, GitHub, and many others. But we wouldn't be here without the community. Unique to Red Hat, I think, is how we co-collaborate, not only within communities, but with our customers directly. And so, another piece that we've been participating in has really been to create a new CNCF Sustainability Technical Advisory Group. We recognize that many organizations are looking at what is my carbon footprint? How can I reduce the costs as I grow to scale within my organization? This technical advisory group and projects like Kepler, which I hope you'll go to the talks this week at Kubecon, will talk about how do we consistently measure that within the data center, report that, and then eventually make intelligent decisions around scheduling to be able to leverage things like edge, the low power, low cost, do your AI ML out to the edge. Another foundation that we are leading this year is the Open Programmable Infrastructure Foundation. We recognize that hardware is quickly becoming very relevant again. With ARM and RISC-V being brought into the data center, how do we not disrupt the way that we've created jobs, but still be able to leverage these different architectures? And then lastly, Luke Hines, who works in my office, is one of the heads of the OpenSSF Foundation as an elected leader. Taking security into the next frontier, so we're very proud to be part of that. But today I wanted to announce that we're actually creating a new community. So you'll see, within the diagram that Diane showed, taking all these pieces and parts together. I didn't see her slides ahead of time. It just is serendipitous that it worked out this way. There are many people that contribute to many different pieces of this ecosystem, and it is complex. And to say that it works right out of the box is not always true. So as people take OpenShift into their organization and they manage it themselves, we want to hear from you. We want to co-collaborate with you to understand how we as a community can help operate these systems better together. And we also recognize that, we've been heavily tilted on the developer persona, and we recognize that the SREs, the people in the trenches keeping these things alive, have a hard job. And there are not a lot of shared tools, and there's not a lot of openness in that community. So we're inviting you today to come develop tooling, technologies, and a community of practice, and create transparency across all of these platforms to really drive innovation, because that's what we believe the beauty of open source is. So you can either scan the barcode or go to opt1.st/SIG-SRE and join that community today and start contributing to making these things operationally excellent. So, and I just want to thank Diane in closing, trying to get us back on time here. Diane invited me to be part of one of the first commons a long time ago in Seattle to talk about big data at Red Hat, which we don't even do anymore, so that tells you how long we've been here. But she has been a catalyst to many people in their careers, so thank you, Diane.